A corporate policy is a static document. A neural network is a dynamic, multi-layered environment. Bridging the gap between these two worlds requires imposing a strict, verifiable structure over an inherently chaotic system. This creates a distinct challenge for technology auditors. They have to mathematically and systematically prove that a complex artificial intelligence management system, or AIMS, conforms to the safety constraints defined by international standards. A common misconception is that an audit is simply a subjective review of corporate practices, or a light touch of a checklist to ensure policies exist. Auditing an AIMS under ISO IEC 42001 is a precise, comparative discipline. It relies entirely on hard logic, demanding physical proof over human interpretation. Executing this discipline requires three foundational pillars: setting specific objectives, applying unyielding criteria, and extracting high-reliability evidence. Without this rigid mathematical framework, an organization cannot genuinely claim its AI is safe. It can only guess that it is. The process begins before any evidence is collected. The foundational axiom of the entire operation is the audit objective. This defines the explicit purpose and scope of what the auditors intend to achieve. Within ISO 42001, these objectives usually target specific outcomes. An auditor might aim to determine strict conformity to the standard, assess the overall effectiveness of the AIMS, or execute a Stage 2 certification review. Every objective must pass through the SMART filter. It must be specific, measurable, achievable, relevant, and time-bound. An objective fails the filter if it relies on narrative assumptions. It is meaningless unless it explicitly demands verifiable evidence. A poorly defined objective creates an unfocused audit. Auditors end up reviewing irrelevant processes, wasting organizational resources, and ultimately failing to uncover systemic risks buried deep within the AIMS. This flowchart illustrates the audit logic formula, an objective machine used to process compliance. The first input is audit criteria. These are the absolute benchmarks the organization must meet, whether internal policies, specific ISO clauses, or regulatory requirements. The second input is audit evidence. This is the raw, verifiable data extracted directly from reality. Notice the contrast. The criteria represents the standard to be met, while the evidence represents the actual operational state of the system. The output is the finding. This is a direct mathematical comparison of the evidence against the criteria. This formula is agnostic. It does not factor in corporate reputation, a developer's assurance, or good intentions. It only processes verified data. By routing every question through this logic formula, auditor bias is eliminated. A complex AI compliance project is broken down into a series of binary, verifiable truths. The integrity of the finding depends entirely on the inputs. In an ISO 42001 audit, not all data holds the same weight. Auditors evaluate evidence across two metrics: sufficiency, which means gathering enough quantity to prove a point, and appropriateness, which evaluates the quality, relevance, and reliability of that data. This pyramid graph maps out the evidence reliability hierarchy. At the bottom, providing only medium reliability, is testimonial evidence. If an engineer states in an interview their neural network is fair, that is testimonial. It offers a baseline understanding, but a verbal claim alone is insufficient to prove conformity. Moving up the hierarchy, auditors require high reliability evidence. This comes in the form of documentary records, like signed policies, and analytical data, such as disparate impact calculations. At the top of the hierarchy is reperformance. This gold standard occurs when an auditor independently reruns an automated bias test to verify the outputs. A frequent failure point in tech auditing occurs when novices rely heavily on interviews, taking the auditee's word for it, instead of doing the work to extract analytical or reperformance data. Accepting low-tier evidence creates a false sense of security. It leaves undetected vulnerabilities in the system and renders the resulting certification virtually meaningless. Let's apply this theory to a practical scenario: a multi-day Stage 2 certification audit for an e-commerce company's AI recommendation engine. To execute the logic engine across an entire organization, auditors use a rigid, time-bound schedule. This grid shows an audit plan mapped to the ISO 19011 standard. During the morning activities, the audit targets high-level context, leadership, and support. the team reviews foundational documents covering clauses 4, 5, and 7 to establish system boundaries. In the afternoon, the focus shifts downward into the technical operations and controls required by Clause 8. Here, the auditor conducts an interview with the data team, but they immediately cross-reference those testimonial claims against hard documentary evidence, requesting training logs and analytical bias test results. A properly structured audit plan leaves no room for evasion. It systematically corners the auditee, ensuring that every operational requirement is tested against high-reliability evidence. The schedule transitions to day 2. The auditor moves past high-level policy review and begins deep technical extraction. The morning begins with a sampling exercise. The auditor selects 50 random recommendation execution logs. This specific poll tests the organization's transparency and system monitoring under clauses 8.4 and 9.1. Sampling is a rapid analytical test. It strips away the corporate narrative to reveal the raw operational truth of how the model behaves in production. Later in the day, the auditor interviews peripheral departments, like customer service. This checks if the awareness training and risk escalation protocols are actually functioning in practice, far away from the core engineering team. By the end of day 2, the auditor has compiled a massive data set of physical, documentary, and analytical evidence, ready to be fed into the logic engine for final comparison. The schedule is not designed to find faults arbitrarily. It is built to exhaustively verify the aims against reality, testing every single organizational layer. The auditor outputs findings into a classification matrix, categorizing them by systemic impact. The most severe is a major nonconformity. This represents a complete breakdown of a requirement, for example, discovering an entirely empty AI risk register. The consequence of a major nonconformity is absolute. Certification is immediately halted until the organization resolves the fundamental failure. A minor nonconformity indicates an isolated lapse. It is a failure that does not crash the effectiveness of the entire system. Returning to our e-commerce use case, the auditor found 2 customer service agents who were completely unaware of the AI escalation process. Because it is an isolated failure in awareness training, this is classified as a minor nonconformity. An observation is not a direct failure. It highlights a potential future risk or an opportunity to improve the system. In the e-commerce scenario, the auditor noted that the company's model drift monitoring was functional but not fully automated. Since no criteria was breached, this is logged strictly as an observation. These classifications are rigid. They dictate the exact timeline and the precise organizational remediation required before an ISO certificate can be issued. A successful AI audit is a mechanical, objective process executed by competent, independent personnel. Stripping away testimonial subjectivity and demanding high-reliability evidence is the only method capable of genuinely stress testing an artificial intelligence system. Compliance is not merely a static document resting on a shelf. It is an interlocking, unyielding architecture of objectively verified facts. This structural rigor transforms a theoretical risk management plan into an internationally certified, trusted system. In the realm of ISO IEC 42001, truth is not what the organization claims. Truth is only what the auditor can objectively prove.